Excellent. You're here. Now we're ready to move on to types of equilibriums. So, to our PowerPoint post-haste from the current slide. Switch to duplicate, and there we have it. Lecture 6, Types of Equilibriums. Our learning target is based upon you identifying physical and chemical equilibriums, okay? And here we go. What's an equilibrium? Well, these were supposed to fly in, but they weren't, but they did. So, an equilibrium is a combination of two reactions. Both a forward and a reverse reaction are occurring at the same exact time. It's like a two-way street. People moving from, or a hallway in class, right? People moving from class A to class B, and then people moving from class B to class A. At the same time, they're passing each other in the hall. And at the same rate when we're talking equilibrium. So 10 students leave from class A to travel to class B. 10 students from class B move back to class A, okay? The rates of the two reactions must be equal. That's the 10 students passing each other in the hall at the same time. But the concentration of reactions and products must be constant. So the overall number of students in each classroom is constant. For every one that leaves classroom A and goes to classroom B, one leaves classroom B and moves back to classroom A. So at any given moment, there's the same number of students, 10, in each classroom. It's just there's some transitioning past each other in the hall. Okay, so the overall concentration must be constant. Same number of students in each classroom, but anytime one leaves classroom A to go to classroom B, one leaves classroom B to go back to classroom A. So the overall homeostasis, if you want to call it, is constant. Equilibriums are dynamic, and the concentrations of products and reactions are constant. This is an animation kind of showing that. Every time A and B smashes into each other to make AB, and AB breaks apart to make A's and B's. So this is kind of like that passing in the hall. For every reaction of A2 and B2, there's an AB that's breaking apart and traveling back. And you see them passing each other in the hall in that one moment as they transition between the reactants and the products. Okay. Here's another way to think about it. There's a forward reaction and a reverse reaction. For every forward reaction, there's one that cycles back in the reverse. So these are really kind of like cycles, okay? Chemical equilibrium, what is it? That's a chemical reaction. So reactants becoming products and products turning back into reactants is a chemical equilibrium. That requires a chemical reaction to occur. A solution at equilibrium will look like nothing is happening. That's the tough part about this. With a physical equilibrium, we've got more like phase happening, okay? After the equilibrium is established, some of the solid is turned into a gas, and we've got both condensation and evaporation happening all at the same time. The same number of particles stay as a gas, the same number of particles stay as a solid or liquid, but for every one that turns from a liquid into a gas, one turns from a gas back down into a liquid. And that's exactly what I just said. Solution equilibrium is where we've got a precipitate at the bottom of a beaker. And that's a soluble or insoluble product. It doesn't matter really. But for every atom or molecule or polyatomic ion that becomes aqueous, one that was aqueous becomes a solid. So as a crystal dissolves, the ions that are already dissolved in the solution will recrystallize and fall out of solution. For every tiny piece of crystal that dissolves, a tiny piece of aqueous ions recrystallize. To maintain an equilibrium, we have to have a system be closed, because if anything escapes, then it's not part of the cycle anymore. So in order to have an equilibrium, the reaction must be reversible. Most times a system must be closed to prevent products from escaping. Because if you're talking about cycles, and equilibriums are cycles, forward and reverse, nothing can go missing. Otherwise, the cycle gets disrupted and it's not an equilibrium anymore. So if a reaction produces a gas, that gas has to be contained in the container because otherwise it'll escape and you've broken the cycle. So equilibriums are cycles. There's chemical equilibriums, there's physical equilibriums, and there's solution equilibriums. Chemical equilibriums, for every pair of molecules that reacts, a pair of molecules unreacts, so to speak. In a physical equilibrium, for every molecule that evaporates or melts, a molecule condenses or freezes. And in a solution equilibrium, every molecule that dissolves, a dissolved molecule recrystallizes. So these are what equilibriums are, the three types. Thanks for watching. See ya next video, lecture 7. Click the button.